Good. Yeah. All good.
Thanks everyone for coming along and for everyone joining online as well. Those people who don't know me, my name's Carl. I'm a PhD candidate in the School of Historical and Philosophical Studies at the University of Melbourne. So my research really looks at transitions in technology. In particular, or more specifically, I'm looking at how astronomers experience the shift from analog to digital photography. So we're supposed to, in everyday descriptions, the former, so analog photography is really figured as grainy and tactile and imperfect. And the latter, the digital, is figured as clean and sharp and precise and instant. And the received view of these categories, whilst useful, has rendered invisible, I've found, a rich middle ground that's populated by various devices and practices and artifacts that don't sit neatly in either the analog or the digital world. This image on the screen, for example, is it an analog image or is it a digital image? Throughout this presentation, I hope to show you that the answer to that isn't actually very clear. Let's get the next. There we go. All right, so in this presentation, I want to challenge that divide, the analog and digital divide, that boundary. And I want to do that through a select number of cases. So I argue that the binary categories themselves obscure a functional ecology of practice and image making that sits beneath that. So I want to make a simple shift of emphasis. Instead of staging analog and digital as rivals, I want to treat them as partners. And to do that, I want to propose an alternative approach, an approach that shows that making images is part of an extended research practice. It's not analog and it's not digital. And these practices are shaped by local affordances, institutional constraints, and various epistemic aims. So let's jump into an example. So this is Walden. This photograph was produced by Russell Kirch, Walden's father, in 1957, and it's widely regarded as the very first digital image ever made. But that label digital hides a lot more than it actually reveals. So making this image began with a printed photograph of Russell's son. He then took a video camera tube, one that is very much like one of these, an analog device, and essentially scanned the image point by point, so that whenever it passed over a bright part of the image, a larger signal was sent, and that was encoded as a number 5, say the brightest point. And darker points on the image are encoded as a number 0. Now these numbers that mapped the image were then fed into a computer, the only programmable computer at the time in the US. And that computer then rendered the image on an analog TV screen. So there is this image here of the computer system was taken more than 20 years later. But you see the scanning device used by Russell Kirch to produce this image is still there on the desk. And this is the screen that that image of Walden would have first appeared on, the first digital image. So digital does exist here, there's no denying that, but it only exists as it passes through analog hands and analog practices. So this famous example is really a microcosm of how digital innovation actually seemed to have happened. In practice, it was hybrid, it was piecemeal, and it was quite messy. The simple analog-digital framing hides the real work that was done. So if this analog and digital categories blur when we look at how image making is done, then we need a new way to describe image making and this transition. Many of the cases that I've been looking at in my research have hit that blurry boundary that can't easily be categorized. So I've started to highlight different practices that are involved to make that shift of emphasis. These are not exclusive, these are not all the practices, but these are the ones that tend to come to the fore so far. We have the idea of detection, where you take a referent or a scene or even existing photograph, and you detect the light or detect some sort of signal. And there's a process and different technologies involved in that. You have the process of encoding and converting that signal into numbers or into waveforms or into some other format. And I'll show you various examples of that. There's inscription and rendering, making the image visible to the senses, either in data form or as a pictorial form. There's storage and communication, so actually saving or storing the data and the image, and these happen in various ways, and the various choices made there shape what kind of analysis and use you can take on the image, on that data at later stages. These are definitely not progressive steps. They happen all at different times, in different situations, in different cases. And not every case needs to use all of these either. So I borrow here from Andrew Pickering's idea of a mangle of practice, but I want to extend that and think of this more as a braid. That might be strange coming from someone who is follicularly challenged, as I am, but I've come to terms with that and I'm sticking with it. So the idea of a braid here is one that weaves in various practices, technologies, and ideas as they're appropriate at different times. And some of them might pass out into other areas and be picked up in other practices. So using this approach, I think what changes historically in this transition is less of a swap of media, more than a reorganization of the work of image making. So to highlight this point, I want to take a look at an image making process that occurred before the advent of the computer in 1926 specifically. And here I want to ask, can you have a digital image before you have the computer? This image suggests that maybe you can. So this is a sinking ship, the British freighter, the Antino, in 1926, began to sink off the coast of England. An intrepid British photographer snapped this photo by traditional means, flew it down to London where it was developed. It was then transmitted via cablegram across the North Atlantic Ocean where it was reproduced and published in the newspapers. So this quick description deserves a little bit of breaking down. So let's take a look at how this process actually happened. So after the original photograph is developed in London, 5 copies of it are made on metallic plates, each one at a different exposure showing different levels of brightness. So bright portions of an image would appear on all 5, dim portions will appear on only 1 or 2 of these plates. And then an electrical probe is passed over the image, essentially scanning the image point by point. And where the probe makes contact with the metal underneath, a corresponding hole is punched in a piece of paper. And this very long, hundreds of feet strip of paper then encodes the brightness qualities of that image. So each point, a bright point that appears on all 5 images makes 5 holes. A dim point makes no holes or 1 hole or everything in between. The encoded image is then transmitted via cablegram. This was a very popular and common technology at the time. Think of it as a kind of souped up Morse code. And that data was transmitted across the North Atlantic and received in New York by another machine. And that machine then reperforated, it's actually called a reperforator, another piece of paper tape, essentially transporting the tape from one side of the continent, well, from London, all the way across the North Atlantic to New York. And now we get to the final stage. Here we have a light source, the paper tape, a lens, and a piece of photographic surface, another metallic surface or photographic paper or glass. The light shines through the paper tape, and where it encounters 5 holes, more light is passed through, so a brighter spot is exposed on the photograph. Fewer holes, a dimmer spot is exposed, effectively recreating or re-rendering the image again across the North Atlantic. The entire paper strip is processed this way. This whole process takes a number of hours, 4 or 5 hours, a lot faster than popping the image on a ship or even on a plane and sending it over. So this process, convoluted and quite remarkable, actually, I think, includes many aspects of what we might regard as digital. There is conversion of the image into whole or no hole, or 5 holes or 3 holes, ones and zeros, ons and offs, a very digital type of process. There's transmission across electrical wires, splitting the image up into individual segments or pixels, encoding them, rebuilding it, very much the same processes that your camera undertakes today on your phone. But is this a digital image? Does the classification even matter? I'd say it doesn't. I'd say what we have here is a form of proto-digital image that's built atop of mechanical substrates, gears, mechanisms, wires, lights, and lenses. Let's take a look at another case, this time an astronomical one, because that's my area and that's what we're here to see. In 1965, the Mariner 4 probe flew by Mars. On board was an experimental camera, essentially a television camera tube, very similar to this one here. And as it took photographs of the Martian surface, it was converted into numbers and then beamed down to Earth and printed up on reams of computer paper. Again, the numbers, a 63 was a bright spot and a 0 was a dark spot, and everything in between. Engineers started getting tired waiting for this data, and computers at the time would have taken 8 hours to render a single image. So one intrepid engineer, Richard Grum, began to cut up the strips of paper and stuck them onto the wall, effectively reproducing the geometry of the image of that photograph of Mars as a series of numbers. Here's one of them said to be communing with the numbers. But this wasn't enough for the engineers. They divided up the numbers into little groups and assigned a color to them. And they took a packet of crayons and began coloring in the image on the wall, thereby rendering our first space-bound image of an astronomical object as a piece of craft. So over the course of the afternoon, engineers began to become more confident that their experimental camera was actually working. It was actually giving them real data that actually meant something. So is this an analog image? Is it a digital image? Is it a piece of art? Is it an analog rendering of a digital data? I think it could be all of those things. And all of those things, if it is all of those things, none of those things really matter. I think here what is remarkable is the process that was undertaken. So we also have here more than a workaround. So this was a moment of shared verification, creativity, and an epistemic process that wove together whatever technologies and techniques and colored crayons, they just happened to be in the red and brown tones that we know Mars is today. This image now, as a little aside, they cut out the piece of wall because it was literally glued to the wall. They cut out the piece of wall, framed it, and now hangs in the JPL offices in one of the corridors there. So almost 10 years after this, to jump ahead a little bit, we arrive at what many of us would regard the digital era in photography. This probably not so much to look at compared to some of the images we've seen, but this is the first astronomical image taken with an actual digital detector. So in 1969, the charge couple device was invented, and this is a slightly later version of one of them here. And this is made up of a number of individual picture elements. So instead of dividing the image up or scanning it in points, the detector itself, its own geometry and materiality is built in that way. Each of those picture elements is sensitive to light, and this is where we get the word pixel from, a picture element. A number comes out of this through magic of engineering and other equipment that's attached to it. And that's the digital detector or the digital device. You have descendants of these in your phones. So it wasn't until 1974 when engineer James Janasik attached one of these to his backyard telescope, pointed it to the moon, and took this photograph of lunar craters. So this is what we're looking at here. You can see the artifacts of the geometry of the sensor in the little squares and each particular little point. They were quite crude in those days. But James didn't have a computer at home to process this data. Being the inventive and entrepreneurial, I guess, engineer that he was, or still is, he cobbled the signal together into an oscilloscope. essentially a type of TV screen. As the beam scanned across the screen, James wired it so that when it hovered over a particular spot, it would hover for as long as the brightness of that part of the image would be. So if it hit a point that was very bright on the lunar surface, it'll hover there for a little longer, making that part brighter, less longer on other parts, thereby rendering the image on this screen. Then to store the image, he took a photograph of the screen with this Nikon film camera attached to the front of his telescope, had it developed in a darkroom. And that's the digital image that you see here. Digital detection, yes. 5 minutes, yes. Digital detection, analog processing, and film photography. So this was definitely a backyard operation, one of the first of its kind, and quite literally a backyard operation. What about professional photography? Surely that was a little bit better. Well, it was 2 years later that we had the first professional, astronomical image taken with one of these devices. And that's it there in the top right, the image of Uranus. This is Jim, again, at the Cerro Tololo Observatory in Arizona on that very night that this first image was taken. Here in 1976, yes, astronomers took their first image. I was speaking with one of the astronomers who were there that night, Harold Wright-Seymour, and he remarks that you're taking exposure, you're basically just trying to see if you've got it in the field, and you've got to get the exposure right. And then you go, oh, look at that. I've never seen anything like that before. It was dramatic. It was far more contrast than any picture of Uranus I'd ever seen. So here we have this digital detector above Jim's head there. The computers are actually behind him, recording the signal onto magnetic tape. But from listening to the people there that night, the impact was again made with oscilloscope screens and CRT monitors. This wasn't, to save that image in that moment as well, a photograph was taken just as Jim took that photograph 2 years prior. This time things are a little bit more advanced. They used a Polaroid camera to take the photograph. And this wasn't really a once-off kind of thing. First image, let's take a photograph with the camera. James tells me that, and I quote, JPL literally bought tons of Polaroid film, mainly used for oscilloscope scans. So it seems that this was the process. Taking photographs of screens was the way that these images were stored, as well as the magnetic tapes for analysis. So even supposedly in digital regimes, we find new ways to weave together a multitude of practices and techniques. So what do these stories really have to tell us? Above all, I think they show the strict limits of an analog and digital divide. When we look closely at how these images are made, we uncover what is a very rich hybrid period, a period where proto-digital techniques existed when digital meant nothing more than fingers and toes, a period where crayons are used to render an image of Mars, and digital cameras needed TV screens and Polaroid film to become useful. The language of analog and digital is inescapable even in this presentation, but the terms often blur more than they want to clarify. Analog and digital aren't neat categories that map onto specific technologies or specific moments in time. The terms have always been applied retrospectively and function more as labels of convenience than as markers of any real boundary. When we pigeonhole images and image making into neat before and after narratives, or argue over the definitions of, is this an analog or a digital image, we learn very little about what truly mattered in these processes. I hope that, as I've shown you today, that by focusing on practice, we can illuminate, and that is a pun, we can illuminate what was actually at stake in these transitional moments. This whole presentation is full of puns if you're acutely listening. A practice-based vocabulary, instead, doesn't erase this distinction between analog and digital. They do exist, but the view suggests that the most decisive aspects of technological transitions, at least in this one, are not questions of essence or epochal rupture or abstract taxonomies, but reside in the assemblage of craft skills, local choices, situated problem solving, and creativity. A practice-based vocabulary functions as an analytical tool to help us uncover and draw attention to the hybrid that is otherwise rendered invisible. And thank you very much for your attention.
Look, you have to explain the joke.
My jokes always have to be explained.
Okay, I can see the questions coming thick and fast already.
Sorry, I don't have a name tag. I'm Sam from QT. I came just for today. I'm a photographer, but also have a half a physics degree. So this is fantastic. I had a question that's kind of more about aesthetics than practices, but I'm interested if generally you have any comment. There's this idea in the history of technology, cultural history, about the artifacts and the limits of a technology being what harkens back, what the nostalgia remembers and what people try to recreate. And I was curious if with more contemporary astrophotography and this more computational, whether they have a sense of that, of we need to put in that kind of aesthetic of older technologies. And then the kind of generic question of, do you see that happening with AI as well? Obviously that it's drawn on previous imaging.
Yeah, good question. Thanks for that, Sam. The aesthetics are actually very important in astronomical image making. There's certainly, when we come to things like the Hubble images and the James Webb Space Telescope images, selecting the right ones to go out into public, even the early Voyager images, there were teams of people that would go through and select which ones they would release to the public, which ones made the greatest impact, and highlighted the use of taxpayers' money and funding in this. In the amateur world, certainly when producing images, even your own images of nebula and what have you, certain objects in space have a certain aesthetic that people try to duplicate and copy. The Orion Nebula has certain colors and certain features that if you post an image of that doesn't match up with the expected aesthetic qualities, then it is not a good image. All right. There's even the color choices that people make, because there are no colors in these raw images. The color choices made and the palette used to describe and inscribe on these images are aesthetic choices, and they become fixed into the practice. You need to use these sorts of colors for hydrogen and these sorts of colors for other features. And they've actually changed over time. There are even things now called like the Hubble palette or the James Webb palette and those sorts of things. So aesthetics are definitely a thing there. In one of the examples, the color by numbers example, perhaps moving a little bit away from aesthetics or pushing that a little bit, the PR people were actually very nervous about what these engineers were doing. They locked the doors and stopped other people from coming into the room because it was getting so much attention. They didn't want this crayon coloring to become the image of Mars that they had spent all this money on to be the first image the public sees. So they were kind of sequestered, and there is some footage where you can see equipment or barriers like put up against the walls that people couldn't see in, what was happening, because it did draw a bit of attention. This image came out, not so long after the actual images, but yeah, there was certain that tension and that sense of, this isn't the quality or this isn't the aesthetics that we want to show of our new computing world and all of that. I don't have much to say on the AI world. That's sort of outside of my remit at the moment.
Thank you. I was also going to ask about AI, but I won't now. I was wondering, I really enjoyed it. It was really, really interesting. I love your PowerPoint was so impressive.
Props.
And props. I know,
yeah.
Show and tell.
Pulling out all.
I was wondering whether astronomical imaging now is exclusively digital. And is there anything lost in that, in your opinion?
That's a really good question. Yes, certainly we have moved to an entirely digital space. What we've also moved to is less of the image and more of the data. So astronomers tend to work less with the actual, full color images. Those tend to be, my sense is more, PR and public and outreach and those sorts of things. The astronomers I've spoken with just work with the data and they love the digital realm. No, well, they do, but they don't. There is even, Yes, but you can look back even to the late 1800s, early 1900s for a sense of similar. We had the photographs on glass plates and they were converted and measured into tables of data. So that process has always been there. But the images, I think, have taken on a different sort of role. We are very firmly in the digital space. I think aesthetics still play a role, but for different reasons.
Am I allowed to interject there with
Yeah.
Anton Pannekoek?
Yeah.
So
Oh, yes.
as late as the 1920s, Dutch astronomer Anton Pannekoek was making the argument that drawings of galaxies and nebulas were better than photographs. I mean, that's still, you know, pre-digital, but like was making the argument that the aesthetics, that you got more detail and you more relevant detail from a drawing than you did from a photo. It wasn't a very popular opinion at the time, and it didn't last very long, but that's an indication of how late that, you know, sort of argument was still going on.
Hi, thanks for that great talk. Can I have a copy of your thesis when you finish?
Yeah.
Awesome. No, it's just because my thesis is
I
on
know.
oscilloscopes. So
Yeah.
yeah, well, part of it is anyway, and the rest is on LCDs. I'm really interested in the kind of 1926 Antonov sinking picture that you discussed, and you called it proto-digital. So I guess my question is around the concept of digital as a concept of transmission, and I'm not sure if you've kind of thought about that, but typically kind of with Baudin code and in the 19th century, the reason why, even though there is encoding, as you kind of, you know, pointed out, the reason why the 19th century is kind of not considered a digital in kind of like electronics and transmission is because the way that the electricity was pulsed down the wires was like continuous, right? And it's not until like the 20th century that we have discrete. So I wonder if you're gonna like talk about that in your
Yes,
thesis.
yeah.
Okay.
Thank you for that, Louisa. I admit I was being a little bit provocative about implying that maybe that was a digital image in 1926. But you're certainly right. It wasn't until the 1950s at the cybernetics conferences, the Macy's conferences, that we start to see this idea of digital arise, and the definition, you know, was made in contrast to analog, which was continuous, and digital was discrete or chopped up. But that definition didn't seem to stabilize until quite some time afterwards. Even at the Macy conferences, they were just used to sort different types of projects and things that they were working on. Yes, yeah, absolutely. Yes, yeah. There were records of this debate about what does this word mean and what are we using for, and its definition has changed over time. So, yeah, I think I'm just being a bit more provocative. They definitely didn't call it digital, and I don't think it is digital, but it is digital-like in some sense. Yeah, the transmission was certainly continuous, but the breaking down or the quantizing of the image itself into 5, 4, 3, 2, 1 dots, yeah, has remnants or, you know, suggestions or something like that. Yeah. I like being a bit cheeky about these things.
You're exploiting your practice-based lens.
Thank you. Yes, I am.
Okay, thanks, Carl. Everyone.
Thank you.